Welcome to the third and final part of 3.1, where we explore the intermediate value theorem, the zero version. The intermediate value theorem can also be labeled IVT for short. Now, we want to first talk about why zero is so cool. Zero is such a neat number and has an interesting history, and if you'd like to look into it a little bit more, I highly recommend it. It's an interesting number because it's the absence of any number. You know, we sort of think about the colors white and black and how I can't ever remember which is which, but one is the absence of like color and one is all the colors. Zero is kind of like that for numbers, which is why it's so cool. Another big reason why zero is so cool, at least to me, is that it is the great divide between the positive and the negative world of numbers. If we ever jump from positive to negative or negative to positive, we have to cross zero. And so zero is the great divide between those two worlds of numbers. We are going to use that idea, and the idea that zero is really cool, to explore the intermediate value theorem, which is a theorem that you will use a lot in calculus. And we're going to talk about it today to identify zeros in a polynomial. Before we get into the mathematical verbiage and notation that is the IVT, the zero version for pre-calculus, we will just kind of explore it logically. So let's say we have an XY axis here. It's not going to be anything beautiful because I just want to sketch it real quick and show you the main idea. And then I'm going to draw a function in white, and it's going to be, you know, some random function here. There we go. All right. And I'm going to call this x value right here a, and an x value over here b. And I forgot to label that this is f of x, this function. Now let's think about what f of a is. F of a would be whatever y value this was down here, right? And f of b would be somewhere up here. All right, let's think about what kind of number is f of a? Well, it's down below the x-axis. It's down here. It's a negative number, right? What is f of b? F of b, we don't know exactly what it is, but it's up here above the x-axis. We know it's a positive number. Because we switched from a negative number to a positive number along this interval, this output was negative from this x value a, and b's output, f of b, was positive. The outputs switched signs. They had opposite signs. What do we know had to have occurred in between those? We know that our function had to hit zero at least once. This function could have done something funky and gone up and then back down and then back up a lot of times. But we know that it had to have hit zero at least once. So here's what we know. We know that because f of a and f of b were opposite signs, there had to have been some x value, we'll call it c, such that f of c was definitely zero. That's the intermediate value theorem. Here is the intermediate value theorem, technically the zero version for pre-calculus. So f of x needs to be a continuous function. We don't know that verbiage yet. That is going to be explored in calculus, but continuous just means that it's smooth. There's no asymptotes or holes or jumps in the function. You don't have to worry about that. Our functions will be continuous. So it has to be continuous on an interval that contains a and b, where a is less than b. We're just going left to right. So that's just establishing our function. This will always work. All right, here it is, an if-then statement. That's what a theorem is. If f of a and f of b, so if their y values, have different signs, so one's positive and one's negative, then our function f of x has at least one zero in between those two x values. And I forgot to write a little a here. So in between a and b. AKA, here's a more mathematical way to write it, there's at least one c, right, in between a and b, that if you plugged it in, it would output a zero. F of c is zero. So make sure you have this written down. This is the intermediate value theorem zero version. Okay, here's our first example. I'll do two, just using the same function. All right, we want to use the intermediate value theorem to prove that this function, this cubic trinomial f of x, has a 0 in this interval. So here's our a and here's our b. So our goal is to find f of -2 and f of 1 and show that they have different signs. Then we can come to a conclusion that there is a 0 in between when x is -2 and when x is 1. So the first that I'm going to do is I'm going to find f of -2. So we'll plug -2 in, and your calculator can do a lot of this work, but I do want you to still show your work, but please check on a calculator. All right, so when we cube -2, we'll get -8. Be careful with cubing negatives, it's still negative. Then we square -2, we'll just get 4. Then multiplying, we have -24 plus 16 minus 1. So this is -8 minus 1. F of -2 is -9. All right, so then now I want to find f of 1. It should be positive if we want to prove there's a 0 in there. So when we plug 1 in, that's much simpler. So we'll have 3 times 1 plus 4 times 1 minus 1. So we have 7 minus 1, we'll get 6. Here's the conclusion that we can come to officially. I'll write that in yellow. So since f of -2, which was -9, and f of 1 have different signs, by the intermediate value theorem, we can conclude, and we can write this in 2 ways, so I'll write it both ways. So the first way we can write it is a little bit more wordy, English way. I'm blanking, but this one uses more words. So by the IVT, we can conclude that there is at least one c value where c is in between these a and b values, -2 and 1. So c is in this interval where f of c is 0. That means we have a 0 there. So it says the same thing, just in a more mathematical way. Next up, we'll have a second example, but it will be a you-try problem. So the only thing I changed about the function was that I just took out this 3 here, so we still have a cubic, and I want you to use the intermediate value theorem to prove that our new f of x has a 0 in this new interval from -4 to -1. Go ahead and pause the video and hit play once you think you got it. Here is the solution. We find that f of -4 is negative and f of -1 is positive. Therefore, since f of -4 and f of -1 have different or opposite, either word's fine, signs, by the intermediate value theorem, there is at least, and then you can choose either one of these ways to say it, either using more words or more mathematical notation. So there's at least 1 0 in the interval between -4 and -1, or there's at least one c in this same interval such that f of c equals 0. So we're both saying that there's a 0 in an interval. You choose the way that you'd like to say it. I prefer this more mathematical way because, obviously. All right, I hope you enjoyed today's video. I hope it was nice and short and that you got something out of it. So if you're interested in 0, it's such a cool idea and a cool number. So, all right, guys, take care.